Okay, determine whether or not the vector field is conservative using curl. Oh, what does the curl have to equal for it to be conservative? 0. So it's a higher dimensional version of saying dq dx equals dp dy. So let's find the curl of f, which using the del operator notation looks like a cross product. What does it look like? Well, just notationally, we say del cross f, which then, if we do think of it as it's a weird kind of vector to think of, it's an abuse of notation, but it works. It's the vector, del is the vector of differentials d dx, d dy, d dz. It's supposed to be a funky d. Let me fix that. And then we're going to cross that with the components of f, which I'll just label as p, q, and r, because I'm not going to do anything with it in this step. Right? Question? Nope. Okay, so then we go back to our notation, our pseudo-derivative, or our pseudo-determinant, I should say, from chapter 12. Oh man, it seems like a million years ago, doesn't it? The good old day you were a child. Now you're a man. IJK. You wouldn't go that far. Okay, so IJK across the top, what goes in the middle? DDX. DDY. DDZ. Partials all the way, and then the components, right? Which aren't very pretty to look at. Y cubed z plus 2x. Make sure I copied down right. 3x y squared z plus z for the middle, and then x y cubed plus y for the last. All those look right? You guys are my proofreaders. Look good? Okay. So the operation isn't multiplication, right? That's the difference. When you're taking the determinant, the operation is differentiation with respect to whatever differential you happen to be looking at. So if you cross out the first column, I won't do this for everyone, but for every single one of these calculations, but for this one, cross out the first column and then take the determinant, pseudo-determinant of this submatrix, right? So it's d dy of x y cubed plus y. What would that be? 3x y squared plus 1. So let me say in parentheses then this minus, okay, d dz of 3x y squared z plus z. Jeez, why did I come up with this one?
3x y squared plus 1.
Okay, so it's 3x y squared plus 1, but the whole quantity is being subtracted, right? So what's going to happen?
0.
We're going to get 0 as expected, right? Okay, so that's good. And then a built-in negative right here, right? All right, so now feast your eyes. Don't just focus your eyes. Feast your eyes on just the first and last columns. Cross out that column, right? Then take the same sort of pseudo-determinant, d dx of xy cubed plus y. So that's just y cubed, right? And then minus d dz of y cubed z plus 2x. Hopefully y cubed, right? Just glancing at it, since we're expecting to get 0 here, yep. And then that's the j component, so that'll be 0 also. And then plus, okay, cross out the third column, d dx of 3x y squared z plus z. Okay, so just through d dx, so just 3y squared z, right? 3y squared z, and then minus d dy of y cubed z plus 2x. So 3y squared z, that's the k component, and of course, that whole thing is equal to zeros for each component, or just a big old 0 and then a little half arrow or arrow above it to indicate the 0 vector, which means all the components are 0. So the conclusion? So f is conservative, yay. All right, so that's only part of the problem, right? The next part says we've got to find the potential function. So let's just get this out of the way completely. Okay. So what's your first step? You're going to set f. This time it's x, y, z, f of x, y, z equal to the integral of what? So p, right? P is going to be f sub x. Q is going to be f sub y. Since we know it has a potential function, we can say that little f. R is going to be f sub z. Okay, so the integral then of f sub x, so integral y cubed z plus 2x with respect to x, yeah. So dx on the end. Okay, integrate that for me. It's not too bad, right? Y cubed z times x, but let's put the x in front. So x, y cubed z plus just x squared plus what? G, a constant with respect to x would be a function of y and z. Everybody see what I did there? So that's a version of your potential function, but we have to figure out what g of yz is. So what do we do? What do we do? Take the derivative with respect to y and set it equal to the q component of the vector field, which is f sub y. So we're going to do that. We're going to take the derivative of this potential function I just found. I'm going to leave off the of x, y, z notation. I'm not going to write that every time. So what's the derivative of this component, or this, it's not a component anymore, but this term, xy cubed z, with respect to y? 3xy squared z plus, yeah, that's a 0 plus, yeah, you got to use the subscript notation, or that's the easiest notation to use, I think. And we set that equal to 3xy squared z plus z. Hopefully you can see that this guy, you subtract that from both sides, and they go away. So we can say that the derivative of g of yz is just equal to z. G sub y is equal to z, so you're already integrating, right? Okay, so we integrate both sides of that. If you want to, you could integrate both sides with, what do you integrate with respect to? Okay, so what do you get when you do that? G of yz on the left side equals, if you're integrating, so yz plus some constant, but what is a constant with respect to y? What is a constant with respect to y? So just h of z will work, right? No, we don't need to throw in an x. We already took care of the x's, right? Okay. So what? So what does that do for me? Well, that makes my potential function, this guy, we're a little bit further along the line. That makes f of x, y, z equal to xy cubed, I'm just recopying what I just circled, plus x squared, plus g of yz, which is this whole thing, right? Plus yz plus h of z. So what is my mission now? Find h of z. Good thing I have a third component to do that, right? So what do I do? So we're looking at this guy. That's our potential function. Take the derivative of that with respect to z. Set it equal to this guy, right? The third component. So we do that, and, okay, so look down here. What's the derivative of this guy with respect to just z? Xy cubed plus just y plus h prime of z. Set it equal to this guy. As you can see, we're going to have some nice cancellation. We get, subtract this guy from both sides, subtract this guy from both sides. What do we have? H prime of z is equal to 0. And what does that mean about h of z? It's a true just constant, right? Okay, so what can we take as our potential function? Just, well, this guy. I mean, you could add in the c if you want. And maybe I did that I don't remember, did I do that in the answers? Huh?
On the video.
On the video, I kept a k, yeah, a constant k. Okay, so if you want to be totally accurate, you could say it's x y cubed z plus x squared plus yz plus, I'm calling it c here, so c. So could you check your answer here? Just take the partials with respect to x, y, and z to make sure it's right.